Hi, I want to show you this simple linear electric generator I made. Here we have 700 turns of magnet wire. It looks like it doesn't have a insulator, but it does. It's a transparent plastic coating on it to prevent the current from shorting, and it goes into the turns. It has this cap, and I made these holes to so the air can move in and out and won't stop the magnet. A powerful neodymium magnet. Here's a piece of iron. I drop the magnet into the coil. Close the cap. I want to build a bridge rectifiers to convert the AC electricity into DC so the LED continuously stays on. For that I need a capacitor and 4 diodes. Here are the parts to build the rectifier, and this is the circuit. This diode points this way and directs the negative pulse to this side, and from when that is negative, this one is positive and it goes here, and when here becomes positive, it flows to this side, and the negative from this side goes here. So we always have positive pulses coming here, negative from coming here. And charging the capacitor, a resistor to prevent the capacitor from too much current flowing into the LED, so the capacitor will discharge slower and will give a more consistent lighting. Now I'm gonna connect these to the generator. Before building the rectifiers, I'm gonna test my components and show you some of the values. First we test. I'm gonna show you the coil resistance of my induction coil. It's 27 ohms, which means we can get 1 amp at 27 volt, but the wire is too thin for that, and it probably can give us at 3 volt it gives 100 milliamps, and 200 milliamp at 6 volt. Now test the diodes, see if they are not damaged. This black probe connects to that white line. Okay, that's the voltage drop we will get from each diode when current passes through it. In each cycle, the AC power passes through 2 diodes. Here 1 diode, and from here the other diode. So we'll lose around 1 volt in silicon voltage drop. To reduce that, we can use a germanium diode, which only drops 300 millivolt instead of the 600 millivolt that the silicon diode drops. If the diode is shorted, we will get around 0 volt in the diode test. These are healthy. Now test the capacitor. It's 200 to 120 microfarads. My meter is a bit slow. $230, and this resistor, it's a 12 ohm. Now let's build the circuit. I use these strands of copper to connect my components so I can reuse them later if I don't need the rectifier anymore. Instead of soldering them permanently. This is the how you connect the diodes. Different polarities is for the AC, the line, and the other side. Different polarities is the AC. The sides that have diodes have the same polarity pointing together. This is the DC output here and here. This side gives it plugs the negative and it allows the positive come this way. This side is positive, this side is negative. And you must connect that correctly to the electrolytic capacitor because it is polarized and reverse connection will damage the chemicals inside of it. Okay, this is complete. Now I connect the shake generator or linear generator to it. It doesn't matter which wire you connect to which side because it's AC. The polarity changes. Now let's see if the voltage is high enough to power the LEDs over the diodes. Only one of the diodes turns on because it's DC power and I have connected my LEDs in reverse polarity. Before the rectifier, both of them turn on because it generates AC power and polarity changes and they of them turn on. Now it flickers, which means we should use a higher value capacitor or higher value resistor to prevent the diode from emptying the capacitor too fast. First, let's test this 390 ohm resistor instead of this 12 ohm. It's much better now, but you can still see the flicker. So let's try a larger capacitor, 6.6 millifarads. It takes some time to charge that. Also, we can measure the voltage now because it's direct current. Well, it gives 3 volts. If we could pair this generator with a rectifier, we can power a sensor or a low powered electronic device that's portable also using a supercapacitor. We can shake this and the benefit of this is that it doesn't degrade over time. See you in the next video. Watch all of my videos and bye.